We talked about this a bit yesterday, and I wanted to give you a different handout on it today. Chapter 7 reminds me of Chapter 4, and there's a lot of notation used, or a lot of vocab used, and you've just got to be ready to identify whatever is given. Like this, oh, that deals with this. The P hat means that. The X bar means this. So I just was going to give you a different handout on that. Our notes from yesterday had that table. Hold on. Our notes from yesterday had a table that was useful. But this just has basically this information from the table, and it expounds on it a little more. So I went ahead and gave you the handout. Yes?
On this sheet you just gave us,
Yes.
a lot of them, like...
I see that because of the Greek letters. Yeah, I'm going to fix it. Okay. I gave them Monday. You don't have them? Here. You can have my copy. I have 2 copies. I've written on it, so it's perfectly. Yeah, with some essential oil drops in it, trying to clear up whatever's going on. Okay. So, as we discussed yesterday, Chapter 7, we're dealing with some vocab basics. We talked yesterday about population and how if you're calculating something with a population, it's called a parameter. We discussed the the characteristics that describe a parameter. We discussed it would be like mu or rho, which I do with a cursive P, and then also sigma. And I'm seriously just stealing that straight from your other set of notes.
Okay, so we don't have to write this.
No, you don't have to. Yes,
I could be wrong, but I thought rho was for correlation coefficient. It was another thing for that. Like that was his, Greek letter for that.
We use it for proportion, correlation coefficient, like on the little calculator screen box thing.
Maybe, I don't know. Because I don't know, I just remember it being like R and rho.
Yeah, I thought it was R.
And then its Greek letter was rho.
My Greek is not so good, but we just did R for that.
Yeah, I don't know.
I don't know. I don't know. That's a good question. Honestly, I don't know. I don't think so. I think we just did R. I don't think we really got Greeky until this point in this class. Well, I mean, I guess we've done mu and the standard deviation being the sigma, but we hadn't really straight up, stuck to Greek until now. And then we talked about how sample goes with statistic. And we were ending class yesterday talking about something called a sampling distribution, which is if we made a collection of statistics. So we've done a bunch of samples and found all these sample means. So the next 2 boxes we're going to spend a little time on today. I'm just going to hit on them now. When we find things, we are either looking for means or we're looking for proportions. Because either we say stuff like, on average, my bottle is filled to 20 ounces, which would be an average mean. And we want to calculate, did our company actually make that mean of 20 ounces? Or we might say our product is filled to 98% capacity, so we're doing a percentage, which would be different. So the X bar and the P hat is just, are we talking about a percentage? Are we talking about a specific number? Are we saying specifically my bottle's filled to 20 ounces, or my bottle's at 98% capacity? And so, depending on the wording of the problem, depends on which notation we use. But I swear it's tomorrow's problem, not even today's. Okay. The thing I want to do first is that cool little activity. Oh, goodness gracious. So, I want to look at the difference between the distribution of a population, the distribution of a sample, the sample distribution of a sample statistic. So, there's this person. So, well, actually, there's a class, and it's a very small sample from a very small population. We have 10 students, and we've labeled them student 0 all the way through student 9. And the population is the scores of 10 students on an exam. So step 1 asks us, the parameter of interest is the mean score, so we want to find the average score. We want to use the appropriate notation and calculate the parameters below. Okay, for the mean of the population, what Greek letter are we supposed to use? So we're going to need a calculate mu. How are we going to calculate it?
I add them all up independently.
Okay, so do it. So when you do it, add them all up, divide by 10, what is supposed to be the answer? I agree.
Sounds like ours, our average.
Now, 69.4 sounds bad, but if you look at the scores above, 82, 62, 58, there's a 65, a 66, we're really not that surprised. Okay, they then ask us to find the standard deviation of the population. What Greek letter is going to be for standard deviation of a population? Sigma. So we need to calculate this. How do we calculate standard deviation?
Isn't that the weird one?
It's the one with all those variables and all that.
Yeah, there is a formula for it. If we're really lazy, though, and we tend to be in stats, because it happens, we could do the stats in our calculator.
Just calculate it.
The one thing Hunter can do.
So I'm going to go on my list.
Yeah, I got two numbers. I'm not sure which one it is.
Okay, I'm going to go to my list, and then I'm going to do one variable stats. So I need to type in all the scores on my list. So I'm going to edit
Maybe read
my
it.
list. Yes, please.
Alright, let me know when you're ready.
I'm ready.
0.
82. Oh, we're going students first.
No, I won't do scores.
62. 80. 58. 72. 73. 65. 66. 74. 62.
Perfect. So I typed that in my L1, so I'm going to quit. When I do stats, I'm going to calculate the one variable stats, and I'm using list L1.
Miss Compton.
Yes,
Do
dear.
you mind if I say something just slightly off topic?
Sure.
In the UK, their grading system makes it so 100 through 70 is an A.
Oh, wow. That's interesting.
Yes.
Okay, so
They're all failures.
I'm going to pause for a second.
Which is kind of sad. That's,
Well-
it made me a little bit sad.
It makes me a little sad, too, that I'm mostly sad that we're so proud of it. Like, and we want to continue to make it more skewed. Like, that's not skewed enough.
I mean, I'm assuming the problem
want
is
to
they
see
don't
more
understand
skewed.
that. Because if not, why would they do